Alright, so we're going to begin our next lesson now, which is lesson 7.4, more about printf and introduction to placeholders. Okay, so earlier I explained to you the printf function, where you can basically put a string of text and it will display to your screen. Now, in the last lesson, I explained to you the way it actually works. Like, for example, if I write printf123, the way that 123 looks in memory is going to be let's fix that. Okay, there we go. Yeah. And then, of course, with zeros at the end. And then, of course, after this point, there could be anything. There could just be any random sequence of ones and zeros. But we're not worried about that. I want to make sure that you understand this. Each character in this printf statement, the 1, will correspond to a byte, to 8 bits that are encoded in ASCII that will indicate what character that actually is. So if I separate these a little bit to make them easier to see, then you should know that this is how you write 1 in text, this is how you write 2 in text, and this is how you write 3 in text. So if I have this written out, printf123, then this string of text in memory will look exactly like this. So if you understand this concept and you understand the lessons up until now, you should be able to understand even what the actual ones and zeros inside of your computer are set to when you run this type of a function. So now that you understand that, the next thing that I want to show you is how exactly these placeholders work. So I showed you that we can say something like int I equals 5, and then we could say printf the variable I is set to, and then we could put %d and I, and you should remember that the output for that is going to be the variable I is set to 5. That would be the output. Let's talk about how this works. First of all, notice that the %d never gets printed. This is because the printf function knows that if you put %d, it is intended to be a placeholder for some other value. Remember that we said before that matching data types is very important. Anytime any function is going to operate on some data, it must know what kind of data it is, how big it is, and how it is formatted. Why? Because as we have learned in previous lessons, the same binary can mean multiple things. A sequence of 8 ones and zeros might be an integer, or it might be a character, or it could be anything at all. The printf function allows you to specify different placeholders depending on the type of data that you want to print. You must always match the correct data type to the correct placeholder. Now, you already learned that %d means integer, but we can look at some other examples as well. Now, let's write a very simple program here. Let's see. All right, so we'll start with this. Now we run it. And of course we have the expected output. The value is 5. %d can also be %i. %i also means integer. So if you have an integer you want to print, you have the option of putting %d and %i. So in fact I could do both. %d. And then I can put I twice. So the first I is going to correspond to this, and the second I is going to correspond to this. And so when I run it, the value is 5 and 5. Percent I is this 5 and percent D is this 5. Now if you can represent it as either percent I and percent D, why am I telling you both? Well, the answer is because you could encounter either one in someone's program, and you should know that they both correspond to an integer. Now, another type of placeholder is %u, and you can use %u whenever it is an unsigned integer. Let's do that. Let's do an unsigned, which means it can only be positive because there is no sign bit. An unsigned integer I equals 5. Then what we can do is we can go ahead and write the value is %u, and we're sending the unsigned integer I as the second argument. And when we run it, there you go, the value is 5. So %u can correspond to an unsigned integer. You can also use %c for a single character, not more than one character, not a string of text, but a single character. And I'll show you how that works. We can use the char data type, char my character equals A. And then here I can put %c, which means single character, and I would put my character, like so. And now when I run this, the value is A, because %c is corresponding to my character, which is set to the character A. And lastly, you can use %s, which is a string of text. For that, we need to put an actual string of text. A string of text. Now, this is a null-terminated string of text. Whenever you write a string of text in C, any string of text, and you put it inside of double quotation marks, it will always be a null-terminated string. So if I put 1, 2, 3 in quotation marks like this, it will be in memory like this. The extra null character is automatically put at the end of the string in a way that you can't see it, but it's there. So always remember, whenever you have a string of text that is enclosed in double quotes, there will always be the null character automatically put right at the end. So in between the 3 and the end will be where the null character goes. So if I was to write it in null, that's where the null character goes. So this string of text 1, 2, 3 is not 3 bytes long. It is 4 bytes long, because the 4th byte is the null termination byte. So if we run this program where we are sending a null terminated string of text to the printf function, the value is a string of text. Lastly, you can mix these values any way you want. I could do %i, and %s, and then I just have to make sure that I match them up properly. So an integer will say 5, 3, and then a string of text. So this 5 will correspond to this %i, this 3 will correspond to this %i, and a string of text to this, and I can run it, and you'll see how that works. I encourage you to experiment with this and make sure that you understand it. So to go over it, %d or %i is a signed integer. That is an integer that can be positive or negative. It has a sign bit. %u, unsigned integer. %c, a single character. And %s, a string of text that is null terminated. Now remember, a single character is not null terminated. That is 1 byte. So it is, so for example, if I were to say char my character equals 1, then inside of memory it's going to look like this. That's it. That will be the entire variable my character. There's not going to be a null termination or anything else. It's just going to be that 1 byte. Remember that everything I just explained is also on the website highercomputingforeveryone.com on lesson 7.4. If you have any questions, feel free to ask.